Hey Dad, how are you?
Good, son. How are you?
Good. Well, it's been a while. We've had about 4 months of cold weather here in Colorado. So we have been, well, we all had to work. But I've done a lot of CAD in the last 4 months. And we did some significant upgrades to the Snapmaker. So right now, Snapmaker is calibrating itself. Doesn't look like it's doing it successfully, but there's a lot going on. Yeah, it's making fuzz right now. So it got the dual extruder and the quick change kit and a bunch of stuff.
Which means what? With a quick change, what's going to change from
So
cutting to laser or what?
exactly, the machine does three things. It cuts, it lasers, and it's a 3D printer. So now it's like camera gear. Okay, it's got a dovetail shoe on it now, as opposed to it taking like 30 minutes to change this machine out from one to the other. It's just you flip it and you take it off, and you can take the bed off, and it's awesome.
Cool.
The machine also wasn't particularly stiff. They made a stiffening kit, so I got all of that stuff. It is now very stiff. And then I'll turn it off here. I finally mounted the emergency stop switch. So you can quick change by just unlocking it, and you can also switch out beds by just unlocking it, sliding it.
Okay, cool.
Okay, this used to take 30 minutes. This is awesome. They needed to do this from day one. Also, I used to be able to just push with my finger and it would deflect. It doesn't do that anymore. Anyway, this is going to be a much more useful machine, but I still have to dial it in. It has to calibrate both heads. And right now I have probably the hardest scenario for it to do that with. I've got carbon fiber nylon 10 in this thing, and then on the other one I've got PVA.
Which is?
Polyvinyl acetate. It's basically the same stuff that we use for mold release.
Okay.
Polyvinyl acetate, but it's water soluble. It's a water soluble plastic, and so we'll use it to do all of the support structures for the 3D prints. And then you can just dunk it in the hot water tank and it'll just dissolve.
Dissolve your support.
Right, but I still have to dial it in, and right now it's not sticking to the bed, so I'll probably end up pulling this off, just going to PLA and getting this particular calibration.
Where would you use that versus the PLA? I mean, what you got up there now, that new one?
That's a legit structural material. So the stuff that we've been using so far is
LA there, which
right.
is did that have
like creoc acid? It is designed specifically for. It's biodegradable. It's very strong, but it's designed, and it's very easy to print on these machines.
Okay.
Okay, but right now I've got to dial in the bed temperature for this stuff. It just doesn't want to stick, so I have to solve my sticking problem. Right?
Get it used to.
Right. I have to figure out what the settings are for this machine to do that. But yeah, this is.
Did you have any of that support that you dissolved off of that, or not? It wasn't necessary.
For this one, you can see the roughness inside.
Okay.
It had the supports made in the base material. I had to take them all off.
Okay.
It'll leave a much cleaner finish on the inside.
And you just have to dissolve instead of scraping it off or pulling it off.
So
okay.
I want to figure that out.
Yeah.
Anyway, for us here with this machine, being able to do carbon fiber filled nylon, it's kind of a game changer. It's a big deal for us. For small non-flight flight critical parts, that the sticks and all the stuff in the cockpit.
Right.
We're gonna do all of that. Speaking of that, so we've got Fuel Tech. And then Fuel Tech makes this beautiful little.
We looked at that earlier, didn't we?
Fuel
Tech, yeah.
Fuel Tech we looked at earlier, yeah.
Well, that doesn't mean we don't need a little refresh, but these are the buttons that go with the Fuel Tech, and it's a gauge that monitors everything on the machine, right?
Exactly, and it's got some I/O that we're going to use to monitor things like flap positions and gear positions.
Cool.
Okay, and then these are CAN bus operated switches, and we're going to use those for fans, and there's a variety of things that we're going to use that aren't on the stick.
Are those enough buttons?
No, but we have buttons on the stick and
yeah.
the throttle. Okay, so we've got all the trim switches.
Those will be buttons you don't use right away all the time.
Exactly. Turn the lights on.
Okay.
Right? Landing lights.
Maybe cooling fans.
Strobe lights, cooling fans. This type of stuff. Everything that you need to do, all the flight critical stuff. Is on
your
the
pre-flight.
Stick. It's called HOTAS, hands-on stick and throttle, or HOSAT, hands-on throttle and stick. I don't care. Developed by the military in the 80s.
Okay.
70s and 80s for the F-16, F-15. Okay, and it's a great idea, so we're using it. So everything that you need to do to fly the airplane is on the stick and throttle, right? With a couple of exceptions. Number one, you don't need the gear switches here. That's actually not a great idea. You need to have certain things you need to reach up to do.
Okay.
Right, so reach up, do the gear, reach up, master switch. Those types of things should not be anywhere near your.
Where you could button them or anything. There should be a positive stroke or some kind.
Exactly. Yeah. So this, and we'll walk over here, Dad. You can probably turn it off. Okay, so most of the CAD work over the last few months has been on this incredibly complicated thing with all. This is like the most systems intensive part, so that's why I'm tackling it over the winter. This will go about right here, and below it will be the breaker panel and the main switches, and I'll back all of this up with CAD. And then up here was the radio stack, and as Katie and I worked out last year, we have recessed the main iPad back about 3 inches. Okay, and this will open up, allow you to access this. So we're not going to hinge it back here. We're just going to. I have there's a duct here, and again, I'll show this in CAD.
Sure.
There's a duct here, and it has a little lip, and it'll just grab this lip, and then we'll just screw it in place. There's no reason to have that come off anymore, since you can open this up and put your hand straight back there. This is a mess, but this was our design process for all of this. I have captured all of this in CAD. There'll be a duct here, and then back in here there's a stack of heat exchangers, one for cooling and one for heating, and then a fan, and it'll blow up through here and blow air out here like a knife
into the pilot and co-pilot,
over your feet.
Yeah. You go on your feet too, huh?
Yep. And we'll probably cut a hole right here so that it defrosts.
Oh yeah.
Okay, so that's a pretty.
They're pretty good, pretty strong fans. I mean,
it's a big one.
Yeah.
A big Sanace, like a 200 CFM fan, so it should do it. And yeah, all of this is catted up. This will come out, fold down into a tray, and there'll be an iPad on the back. And yeah, so yeah, I'll show all of this in CAD.
This thing is going to have the characteristics of like a World War II fighter pilot plane, right?
Yeah, we're shooting for being able to, be able to do 220 knots indicated.
Yeah.
At altitude. Yeah. Okay, so that's indicated.
Aerobatics won't be any problem.
This isn't an airplane you want to do a whole lot of aerobatics with, but yes,
but
loops.
You can do snap rolls.
Not snap rolls.
Okay.
No.
Those are the hardest on it, huh?
No post-stall maneuvering at all.
Okay.
It's just not that kind of thing.
Yeah.
But loops, rolls, a little bit of inverted, but it's mostly just for it's a place you can be for 6 hours and get somewhere.
Yeah.
And have a good time in and
be
maneuverable,
reasonably priced,
reasonable, and yeah,
and good on fuel. Yeah.
Good on fuel. All of those things. But yeah, you're not going to win the National Aerobatic Championship in it.
But it's going to be still going to be spunky. Huh?
Spunky.
Yeah.
GT.
GT. Okay.
Grand Touring.
Grand Touring. Right. Gotcha.
Okay, so this is what's going on here, and then the build. Well, it stopped here about 4 months ago. So I'm doing some pattern making for the closeouts for the spine. So this is a bulkhead. This is a pattern for the bulkhead. Okay, I'm going to fill this with filler and capture this. I'm going to capture this whole shape so that I get it precise, and then I'll have to make a mold of this, and we'll make a part. This is a rib, if you will, and then this is a forward rib, and it goes.
Well, that's nice looking stuff.
Goes like this. Okay, it goes about right there. Get that, and then the flat plate.
That's a pretty solid rib too, isn't it, with all the way it's designed? I mean,
So yes, it's
pretty strong.
so all of these are kind of stiffening features.
Right.
All right. The original design was to close all this out, but I can't afford to close stuff out.
So
I gotta be
you
able to
cut
get
the weight.
I have to be able to get to the backside of it.
Oh, okay.
Okay. And I need. This is actually a pretty important structural piece.
Right.
It doesn't really look like it, but it is.
Looks pretty nice to me, but I mean,
Because of the way the loads resolve in the fan, in the duct behind you.
yeah.
This has to be strong and bending this way.
Okay.
Because any torque this way will result in bending this way.
Okay.
So there's a lot of uni that goes down through here to resolve all of that bending force. And that's what keeps this stiff without having really anything in the middle. Because the middle is occupied by the propulsion. And the skins on the outside of those aren't really just along for the ride. So, yeah, this is where the build stopped. I go and I CAD it up, and then I print out full-size stuff. If I had a CNC router, I would throw this on the CNC
It's
router.
like
but
making dresses. They cut out the patterns.
you
Huh?
put the patterns out,
Yeah.
and then you go to town. So yeah, that's what happened. This is where the build is. I'm going to seal this in epoxy, and then I'll.
That'll make it even stronger, right? I mean,
This is just a pattern.
oh, okay. That's just a pattern.
Yep.
Okay.
I'll make a mold of this, and then we'll make carbon parts.
Oh, okay. Okay. Gotcha.
Actually, this will all be one carbon part, with the exception of this rib.
This insert.
This is the rib, okay, and then this is the rib that supports it, and then the vertical stabilizer goes right here,
Oh, that's where the vertical stabilizer goes. Huh?
and then the spar bonds in right here,
Okay.
and then that clips on right here and bolts in.
Oh, okay. Wow. Yeah.
So Katie and I did this over the winter. These two are done. It's just been sitting here. This is roughly how it goes. It doesn't have this. This is still the fixture.
Yeah.
But that's basically how that goes.
What's gonna go?
Yeah. And then we'll do when he gets his head above water. They bought another airplane. They bought a Citation.
Nice.
Very nice. Very nice. They bought a Citation. They figured they needed more speed.
Yeah. Yeah. You gotta get
So
those
he's
doctors
training up
around.
a crew and,
Yeah.
so
Yeah.
He's busy as hell, and I got busy too.
That's okay.
Life goes on. We'll bond these on, and then we'll put the hardware in them,
Okay.
and we're going to use rib nuts. We're going to bond in rib nuts. That way, no matter what, this is going to be a closed out piece. I still have to be able to drill these out and redo them if I have to.
Will you have changed the bearings or anything in time, or?
Bearings are all embedded right here.
Okay.
They're oilite bronze, and they're embedded. We just have to touch the faces of these to expose
If
them.
they get worn, can they be knocked out and changed? Or?
Yeah,
Yeah.
they can. And they can be resized too.
Yeah. Yeah.
Right. So yeah, that's one of the considerations. Is like, I can't really close that completely out. I still have to be able to service it. Right. That's what this is about. This is going to be a very trick piece. This is all going to be bagged as one piece.
One piece.
Yeah. Anyway, that's what's going on. I'm happy with this, but I probably have a day or so just dialing this thing in. And
It's gonna be slick though, man.
yeah,
It'll be helpful.
it's gonna help a bunch. If I can get the carbon filled nylon to work, that's gonna be a game changer. I will just I'm gonna use it for all the interior stuff.
Okay.
It's good for about
Such as.
for, control stick.
Okay.
All
Okay.
of those pieces, I have them printed in PLA right
Yeah.
now.
I know you got
We're
the.
gonna carbon wrap them, and that'd
Okay.
probably be acceptable. But we're gonna print them
Another
and
little
then
step.
carbon wrap them, and they will be.
Give it another step.
Yeah. So that's nice. That's nice. So we're just upping our game, trying to get through the winter, trying to make a living.
It's looking good.
All right. Thanks, Dad.
All right, son.
All right.
Love you. Bye.
That'll be enough.